Hi, my name is Stefan Raspel, and I'm the product manager for Linux and virtualization on IBM Z and LinuxONE. And it's my pleasure to tell you about how to put the I in AI with SUSE Linux Enterprise Server on our great platform. So let's get started right away. Here's a look at the agenda. We have two parts. First off, we'll take a little bit of a look at the background of everything we need to know about, like what hardware facilities do we have in our hardware to accelerate, for instance, the application of AI or also likewise machine learning models, before we later on take a look at all of the AI frameworks or software which is actually taking advantage of that. So without further ado, let's dive right in. And sorry, I clicked a little bit too fast here. So here is an overview of the two main facilities we need to talk about, which is, of course, the AI unit on our Telum processor on the left-hand side, and the SIMD core vector instructions on the right-hand side. The integrated facility for AI on the left-hand side is an AI accelerator, so it provides a couple of complex AI operations and other floating point format operations, which are typically found in AI models, neural networks to be more precise. And we'll take a look in a moment at how exactly that works on our chips. The right-hand side is SIMD core vector instructions. Now, in contrast to the Integrated AI Accelerator, which only became available with IBM Z16 or LinuxONE 4, the SIMD instructions have been around for quite a while. They were actually introduced with IBM Z13, and that means to take advantage of those, you don't need to have the latest and greatest hardware running. Now, what's the SIMD instructions? Well, that's a set of specific instructions which have been revisioned for the past couple of generations of IBM Z and LinuxONE hardware, and they run on a total of 3228-bit wide vector registers. And you can fit a couple of numbers into each of these vector registers, depending upon how wide you decide to have the format for the numbers. And you can apply multiplications or other arithmetic operations concurrently with the single operations for all of these numbers you fit into the vector registers. You can get a very nice boost with that. And again, this is very likely to find some good application in neural networks or other machine learning models. And like as I said, C13 and above. So it's something which you are very likely to be able to take advantage of. But back to the AI unit, here's a little bit of a picture on the right-hand side of what that looks like on our chips. So the cores are, we have a total of 8 on each chip, and they're all getting served by one bigger AI accelerator. We also could have likewise put the AI accelerator onto each core. However, we wouldn't have been able to fit such a big AI accelerator as we actually did if we had to split on the core on each core, because there's only limited space available. And this is something very common in chip design. You just have to come to work with what you have in terms of area on the chip. And since the probability of already even more than a single core, or two or more cores rather, exercising some AI-related operation at the very same time is very, very slim. So would we have put an AI accelerator on each core? That would have actually been a waste and not provide much more value. However, what does provide more value is coming up with a more powerful, bigger AI accelerator, just like we did here. Now, why did we put it on the chip? Well, latency, really, that's about it. If you're considering to exercise or apply an AI model using just a software implementation, like here in the topmost bar, chances are that will take too long and it will blow your budget if you have to decide in a mere matter of a couple of milliseconds whether a credit card transaction is fraudulent or not. Of course, you could consider to export the data to some other platform where you have a PCI attached AI accelerator available, which is the bottommost bar. And that is arguably faster if you just consider the mere application of the AI model on that PCI attached accelerator. However, the problem is that the overhead of sending the data over to the remote machine through the network, which also means you have to involve the device driver, the PCI bus, and whatnot. And likewise, when you're done and have to retransmit the result, chances are it's just taking way too long. And again, you're going to blow your budget. So what we did is we, as you saw in the previous chart, we put the AI accelerator right on the chip, and you can exercise the acceleration with very, very small overhead. You do have a small number of preparation steps and some minor post-operation operations, but that's about it. And that is why you are now able to attain such great, very low latency AI operations. But this is not just a theory, this is actually reality. So we did have a client which was actually struggling with exactly the scenario I was outlining before, which was credit card detection, credit card fraud detection, where they just had a very small time window to detect whether or decide whether a transaction is fraudulent or not. And with the previous approach, this took up to 80 milliseconds, which was way too long because the credit card companies want to have great service for their clients and want to have transactions work out almost immediately. So every millisecond counts. By utilizing our technology, they were now able to do it all in a mere single millisecond. And that, of course, means they can now cover a lot more of their credit card transactions and don't have to give some of them a pass because they couldn't be exercised in time. This means they can cover more credit card transactions. They can detect more fraud, and that translates back to saving actual money for them. So very worthwhile and great story for us in our technology. But there's more to it. If you avoid sending the data off to a remote server, like indicated here in this picture, right? So on the right-hand side would have that remote server. That means you would have to have your data leave our platform. Now, we're very proud of the great security that our platform provides. And as soon as you leave the perimeter of our platform with your data, that already means there's the potential for some additional exposure to potential attacks by the bad guys. Now, if you leave everything on our platform, that means your data is protected. So again, doing it all on our Telum processor or even with SIMD instructions also benefits you in terms of improved security. Now, what's typically customer use cases? We see four main ones. First one would be fraud detection, which I just elaborated on. The second one would be medical images. For instance, deciding or detecting if there's some cancerous fabric in a sample, right? This is a very typical example. There's also federated learning, which is important in case you have a couple of companies you want to join their forces in a company, but do not want or cannot even for legal reasons exchange their data with one another. So what they do is they train models individually, and then they put together the resulting models, not the actual training data. And the fourth one would be chatbot services, which is just classic, right? You have a large language model, and then you train it on a specific set of data, like specific manuals or maybe client cases and whatnot. And then you utilize that to have it interrogated by your call center employees, for instance, or your clients on a help desk, something like that. But there's more, of course. So with the next generation, which we have already announced last year at the Hot Chips event, we have the Telum 2 processor, of course, with a new AI unit getting ready for release, as well as a Spire hardware accelerator card. Now we'll take a look at the TLM2 processor and the intelligent routing, or remote AI as we call it, on the next page. And as far as the Spire accelerator card is concerned, that one is giving you a total of 32 additional AI cores on a single card. And of these cards, you can actually fit up to 48 pieces into your IBM Z or LinuxONE machine. So that's some incredible power right there. Now, as far as a remote AI is concerned, here's an illustration of what that looks like. As you might know, each chip has a total of up to 8 cores, 6 of which are usually available for users. The others are used for things like I/O, for instance. And they all share a single AI unit, as we saw a couple of slides before. Now, would it be great if you were able to actually utilize not only that single AI unit on the same chip, but also the AI units on the remote chips in the same drawer? That's exactly what we're doing here. So what you can do is now you can actually take advantage of the AI accelerators, up to 8 in total, which are available on the other chips sitting on the very same drawer. That's to come later this year. So keep your eyes out for open for that one. Now let's move on to the AI frameworks on IBM Z and LinuxONE. First off, here is an overview of all of the different AI frameworks we have. We distinguish between 4 levels of support, while the first one at the top would certainly be a trivial one that's not supported on IBM Z. There's things like Olama, which is currently in progress of being ported over to our platform. And that means it once it's available on our platform, means it can be compiled, or the ISV is shipping code for our platform. So that's the case for a couple of these frameworks here, like Spacey, Bliss, Onyx Runtime, OpenCV, and so on and so forth. Llama, for instance, is in the process of getting additional support in the form of getting enablement for SIMD optimization, which we talked about earlier. There are a couple of frameworks which are already SIMD enabled. That's, for instance, Leaf, NumPy, OpenBLAS, and Eigen. And out of these, NumPy is actually in the process of moving on yet to the highest form of support, which would be the exploitation of the Integrated Accelerator for AI. So Onyx MLear, SnapML, TensorFlow, PyTorch, they already do so. So they are exercising not only SIMD optimization, but also the AI unit on our chips. However, you can imagine that just porting each and every open source framework under the sun onto our great platform can get a little bit tedious after a while. But there's something great out there which helps us a great deal, which would be the Onyx standard for exchanging neural network models between various frameworks. Now, chances are that whatever open source or commercial neural network or AI framework you're using, it does support Onyx. We'll see that in a couple of slides. And if that's the case, there's Onyx MLear available, which is basically compiling the respective neural network model into binary code to our platform. And then, depending upon what exactly the model needs, the code can exercise either the AIU or the SIMD backend. So we're basically taking the best of both worlds. Now, as far as Onyx is concerned, let's take a little bit of a closer look. What exactly is Onyx? So as I mentioned, it's actually standing for Open Neural Network Exchange Format. So that is an open format for presenting AI models. So you basically define the computational graph model and everything else that's associated to and required to actually run the model and pass in data, read out results, and so on and so forth. Again, on our platform, this helps us a great deal, as I already elaborated, because Onyx is so popular. And we have on the next slide a couple of the ISVs which do support the Onyx multi. So it's quite a bit available here. You can see a very wide variety. And there's more in process. And there's also very prominent frameworks like SUSE, for instance, which is really big, originating from statistics, actually. That's what they are renowned for. Also, other huge players like Microsoft, Nvidia, and Sony, Siemens, and whatnot. So Onyx is a really good thing, and that is helping you getting hardware support for AI acceleration, even though the actual framework producing the respective model might not even be aware of our platform to begin with. If you want to take advantage of some of the frameworks specifically compiled for our platform, because the support only went into our hardware into the respective package at a certain point in time, there is our container image registry. It's fully compatible with SUSE Linux, of course, so you can readily run it on SUSE Enterprise Linux as a plain container image. And the good thing about our container registry, of course, is this image is constantly getting scanned for any fraudulent or faulty software packages. So we're basically guaranteeing you that these are all legitimate and clean versions of the respective packages, providing you the very latest hardware acceleration support. And you do not need to worry about, do I have the right version? Should I test for it? And so on and so forth. There's also another option, which is the AI toolkit for IBM Z and LinuxONE. And this is likewise getting shipped as a container image. And again, providing several very popular components for applying open source frameworks. So you might want to check this one out. However, there's more to it, which would be our secure execution framework. Now, you might be wondering what that has to do with with AI, but bear with me. So, what is secure execution? That is our framework for providing a confidential computing implementation. What we're doing is we're protecting both the guest memory and the guest state as found in our Prism hardware hypervisor. So whenever a bad guy would try to attack either of these two components, which is illustrated by the red arrows, we would protect them through access controls in the case of QEMU, and through likewise access controls being operated by the so-called ultravisor inside Prism. And the respective attacks would be depleted and no data could be ever attached. So with this framework, what it means is that not even the operator of the respective KVM instance would be able to look or inspect the guest memory of your KVM guest and read out any secrets or some such. Your images would be totally protected. Also because they are encrypted and can only be decrypted on the machine they are intended to run on. And if you now combine that along with our AI accelerator, that makes for a great power couple. Because our AI accelerator is sitting right on the chip, that means it's available as mere opcodes or instructions on the CPU. And therefore, you do not have to worry about how to pass in, for instance, a PCI-attached AI accelerator into a secure guest, which is not trivial because you have to make sure that that PCI device you're passing into the secure guest is actually legitimate and not just a fake one which some foe is trying to make you use so he can read out your data under the covers. So by taking advantage of our on-chip technology, we do not need to do anything extra here. And that, of course, applies not only for the Integrated AI Accelerator for AI, that also applies to the SIMD instructions, which we have been checking out at the beginning. So you're getting it all, basically. You're getting very secure access because the data does not need to leave the realms of the secure guest. You're getting very low latency because all of the operations are right on the chip. And that makes for a great experience and great protection of your data when deployed in a secure execution guest. And that's pretty much what I wanted to show you here. So here's a couple of more pointers, for instance, how to reach us, how to get in touch with us. There's also the email address here on the lower left of my dear colleague, Andreas Krebel. So he's our expert for AI and SIMD, of course. And if you have some further questions, feel free to reach out to him. We also offer so-called AI discovery workshops where we sit down with you and work out how to best apply AI solutions for your specific business problem. They are available at no charge. Of course, all of the software I have been showing in this presentation is readily available on SUSE Enterprise Linux, or at least compatible with it. So you can, so everything I've been mentioning is can be deployed on your SLES servers. Here's some more details on that aforementioned AI discovery workshop and how to get in touch with us. And with that, and some final references, I'd like to thank you for your attention and hope to see you at a conference very soon. With that, thank you so much, and till next time. Bye-bye.